going to look at the average variable cost today. The previous video I was looking at the average fixed cost. I told you the average fixed cost is the total fixed cost per unit of output. The average fixed cost is the total fixed cost per unit of output, and I said it is also given by the formula total fixed cost over the output or over quantity. Now in this video we're going to look at the average variable costs. Average variable costs refers to the total variable cost per unit of output. This will be the total variable cost per unit of output, and of course to also copy the same formula. Average variable cost will be the total variable cost over output. Let us look at this in detail. So we're going to look at the average variable cost in detail. Average variable cost. So the average variable cost refers to the total variable cost per unit of output. It is found by dividing the total fixed the total variable costs by the output. You say, for example, let's go back to our example. Let's say a school. If a school has 1,000 students, and that school's total variable costs, we are talking about costs incurred on labor, power, water, food, all those running costs. Its total cost for all the students is 4 million Ugandan shillings. 4 million Ugandan shillings. Now, if you want to find for one student, how much did one student pay? How much did they incur to maintain one student in terms of variable costs? So the average variable costs in this circumstance will be given by, we shall get the total variable costs, of course, and divide by the number of students. So we shall get the total variable costs, which are 4 million, and divide that by the number of students in that school, which is 1,000. So when you cancel this with this, you will end up with 4,000 for one student. So that means the average variable cost would be 4,000 shillings in this circumstance. So that proves our point that the average variable cost is given by the formula total variable cost and divided by the total output of that farm. So I want us to look at an example, a real example, maybe to ensure that you have better understanding of this concept. Let us draw a table. You pardon my tables. So we draw a table, put here, and then there. Okay, so we shall have here. So we have let's say we have here output. So we have here the output of here the total variable cost. Then we have here the average variable cost. So I want to use, we all know that now the average variable cost is given the formula total variable cost of output. So you can feel free to pause the video and rewind and understand what you have not yet understood. But let's follow together. Let us say our output is 1, and for that, okay, let me use a different plan. Output is 1. If the output is 1, then the total variable cost is 50. When the output is 2, then the total variable cost is 80. When the output is 3, then the total variable cost is 100. Output is 4, then the total variable cost is 110, and and the output is 5, total variable cost is 150. So they're asking you to calculate the average variable cost. How would you do that? By simply going to your calculator and putting this formula. Average variable cost will be total variable cost over output. When you divide this, put this in your calculator, you'll find what? You find that the here you have okay, you can go on. You can say when the output is 6, here it is 220. When the output is 7, here is 600 and sorry. The output is okay. Okay, here the output is 7, then it's 350, and then when the output is 8, here it's 640. So I want this to bring out the correct picture for you so that you understand this clearly. So that's why I had to add these digits. Okay, good. Now let's look at it properly. Now, of course, follow the formula and divide. So when you divide 50 by 1, you'll have 50, of course. So the average variable cost in the first circumstance is 50. 80 by 2, you have 40. And then 100 by 3, you have something like 33.3. 110 by 4, you'll have something like 27.5. Then here 150 by 5, you have something like 30. Then 220 by 6, you have 36.7. 350 by 7, you will have 50, of course. And then 640 by 8, you have 80. So I want you to get a graph paper and try as much as possible to plot this, because if you look at the way things are looking, the curve slopes. The average variable cost starts from 50, it goes down, it keeps sloping, declining to 33, declining to 27.5. This appears to be its minimum, and then it starts increasing once more. So it is going to create something like this. So if you have a curve and have your output, and we have here the average variable cost, so you have here our 0. At first it is up. When output is 1, it is up. Then when output is 2, it goes down to 40. Then it slopes down to 33.3. Then it slopes down to 27.5. Then it starts going back upwards. It goes to 30. Then it goes to 36.7. Then it goes back to 50. Or 50 was around here. Then it goes to 80. So what you can see is, if you connect these points, if you simply connect these points like this smoothly, you end up with a U-shaped curve for the average variable cost curve. So that draws the conclusion that the average variable cost curve is U-shaped. So when you're drawing the average variable cost curve, it's a simple curve to draw, which is the U-shaped curve. So average variable cost curve is simply illustrated. The average variable cost curve is simply illustrated like that. So it is U-shaped, as you can see. The average variable cost curve. So we put here 0 and we put here your output. Okay, so the average variable cost curve is U-shaped because of a number of reasons, but it is mainly because of the principle of the variable proportions, or because of the law of variable proportions, which explains that it has three phases. Of course, variable proportions has three phases. The first is this first phase from up here up to down here. That is the first phase. Then down here is the second phase, and the last phase is this phase. So from the first part to this one, it is because of the average variable costs are reducing because of the increasing returns to the variable factors. As you are employing the worker is producing more output. Every worker you employ in this particular part is producing more output. That means the costs you are incurring are falling because the workers have a higher productivity with each new worker you employ. When you reach here, you have reached the minimum. So there are constant returns to the variable factor. So here the worker will not add anything to they will keep on adding the same output to the existing output, so it will not change, and this is should be the maximum or the minimum for the average variable cost. Then when you continue producing more output, you go into the diminishing returns, which cause the costs to rise again. So think about a circumstance. For example, the low variable proportion can be looked at like, for example, when you buy ice cream. When you buy ice cream, the first test will give you a very high satisfaction, but as you continue testing the ice cream, the taste keeps on reducing and keeps on reducing, and finally your belly will be full. So should you add more ice cream to your belly, it will keep on it will find a different way of making sure you are aware that you're not enjoying what you're taking. So you have a limit for applying the variable factors. Should you add more, you're going to keep on losing out in the process. So I hope you understand this. So thank you very much for watching this video, and keep practicing that. Goodbye.